In this video, we're going to talk about what does it mean to divide two equations. So for example, what does it mean when we divide x cubed plus 3x squared minus x plus 1? Let's say we all divide that by x minus 2. Or in other words, another way to write this, what does it mean to do x cubed plus 3x squared minus x plus 1 divided by x minus 2? So let's just continue on this example. How can we divide these two polynomials together? So what we do here is we take this bottom one, this x minus 2. We're just going to write it down. And there's going to be two ways we divide. This first method we're going to be doing. This is going to be called long division. Let's put that up here. So this is going to be the first method, is long division. All right, so anyway, we write the bottom, or if it's written in this form, the thing over here, put a division symbol, and then we're going to write this one, or also the same thing, the thing on the top, inside here. So x cubed plus 3x squared minus x plus 1. And now there's going to be a series of steps that we do, and we're going to repeat these steps until we're pretty much done with this problem. And what we do is we look at this first piece, this x, and we look at the beginning, the first piece over here, which is this x cubed. And we want to know, okay, what do we need to multiply by our piece over here, which is x, to turn it into x cubed? And that's going to be x squared, and we're going to put that on top. Meaning, so again, x squared times x, that's x cubed. That's why we're putting this here. We want to put the thing here that, what do we need to multiply this, the x, to turn it into this? We need to multiply x by an x squared to turn it into this. So once we do that step, we're going to take this number, this little thing up here, and multiply it by both of these and put them underneath here. So x squared times x, that's x cubed. X squared times minus 2, that's minus 2x squared. We're going to put this in parentheses, put a minus sign, and then subtract these two things. So that minus that is going to be 0. 3x squared minus a negative 2x squared, that's going to be 5x squared. And then we bring down the next piece. So that sequence of steps, that's what we're going to be repeating the entire time. So we're going to do that same thing again. But this time, as before, we took this piece, and what do we need to multiply it by to turn it into this? We're going to do that same step, but now we're going to use this one. So we want to know, what do we need to multiply by x to turn into this one down here? So if we multiply x by a 5x, it's going to turn into 5x squared. So we're going to put a 5x up here. And then again, we do that multiplication thing. 5x times x, that's 5x squared. 5x times minus 2, that's minus 10x. Put parentheses, put a minus sign, subtract these things. So that minus that, 0. Minus x minus a minus 10x, that's 9x. And then bring down the next piece, plus 1. So again, we just repeated that same cycle of steps. Now we're going to do it one more time. So what do we need to multiply by x to turn into 9? 9x, and that's just going to be a 9. So we're going to put a plus 9 up here. 9 times x, that's 9x. 9 times minus 2, that's minus 18. Parentheses, minus sign, and subtract. 9 minus 9, that's 0. 1 minus a negative 18, that's a positive 19. And once we get to the step that there's no more things to bring down, then we're done. And so the last thing for this problem is, let's make sense of everything here. So there's basically 4 main components here. We have this thing outside, just the thing up here on the inside. We got something up top now, and something at the very bottom. And each of these things mean a specific thing. So for example, this thing on the outside, we're going to call that d of x. That's going to be x minus 2. And we call it d of x because it stands for the divisor. So these are going to be the same words as when we were doing, what's it called? Division with just regular numbers, like, when you're just first learning math. So this is always called the divisor. This inside thing, we're going to call it p of x. So x cubed. This thing on the top is going to be called q of x. And that's because that's the quotient. And this thing in the very bottom, whatever that's going to be r of x. So r of x is 19, and that's the remainder. Now the reason why we're doing this is there's a formula that we, once we find all this and we have these things, we can put these into a formula. And that formula is that p of x is equal to d of x times q of x plus r of x. So now what does this mean? Let's plug everything in here. So we're originally given a p of x. The p of x is the thing on the inside, the d of x is the thing on the outside. We're always going to be given these two things, and really all we're finding is q and r. But let's plug everything into this equation. So like, what did we just do here? So we found, so p of x, this piece right here, equals d of x times q of x. So d of x is x minus 2. Q of x is x squared. And then plus r of x, so plus 19. So you see what we did, we're given something, and we were kind of able to factor. We factor this into this times this, but then we have this little plus thing on the outside. So that's sort of the use for this. If we're given two things, we can kind of factor, we're given a p of x, we can factor it by using this sort of method. And it factors, so this piece right here is what we're given. We can turn it into this times this, but then plus that. So later on, we'll do more examples of this. For now, all we really care about is sort of these things over here. This would be the answer for this part of the problem. So let's go on to a different example with long division. So the next example we're going to do, let's do x to the 4 plus x squared plus 3x minus 1. All over x plus 1. Okay, just like before, this thing on the bottom goes on the outside of the symbol, and this thing is going to go on the inside. Now, if you look at the last problem, it's a tad bit different. Let's just write down. The last problem that we just did, we'll put it up here, it was well, at least this is the top part. The top part was x cubed plus 3x squared minus x plus 1. If you look at this one, all the variables count down. We have a 3, then there's a 2, then there's a 1, and then there's a nothing. This one's a little bit different because it goes 4, then it skips 3, then it goes 2, and then you have a 1 and then nothing. What I mean by that, so here's a power of 4. We skip the power of 3, but then there's a power of 2, a power of 1, and then nothing. Here we have a power of 3, power 2, power 1, then nothing. So this one counts down. And we need the inside to count down. And so when you have one like this that skips, so for example, this one skips the x to the 3rd power. What we're going to do instead is, so we're going to write x to the 4. Since it skips the x to the 3 power, we're just going to put in a 0x cubed. Which is fine, 0x cubed is just 0, so all we're doing is adding 0, but we need this x cubed here as like a placeholder. Then we're going to do the plus x squared plus 3x and then minus 1. And now once we write this, we're going to do the same exact steps as what we did in the last problem. So the first thing we needed to do, which was what we did in the last problem, is we take the x and we want to see how do we multiply to turn it into x to the 4. And that's going to be x to the 3. So we're going to put an x to the 3 here and then do that multiplication thing. That times that is x to the 4. This times this is x to the 3. Put in parentheses, put a minus sign. This minus that is 0. 0 minus x cubed, that's minus x cubed. Then we bring down the next one. And that was one cycle. So now we're going to repeat that cycle again. So what do we need to do to turn x into minus x cubed? That's going to be minus x squared. So we do the multiplication. This times this is minus x cubed. This times this is minus x squared. Put in parentheses, put a minus sign. So the minus x cubed minus minus x cubed, that's 0. X squared minus a negative x squared, that's going to be 2x squared. And then bring down the next one, plus 3x. Okay, so again, that was another cycle. So now let's repeat that one. We're going to have to repeat it 2 more times. So what times x turns into 2x squared? And that's just going to be 2x. Now we do the multiplication. 2x times x, that's 2x squared. 2x times 1, that's 2x. Put in parentheses, put a minus sign, and then subtract. That minus that, 0. And this minus this is x. And then what we do is bring down the last one. And then repeat, again, that was just another cycle. So now we're going to repeat that cycle one more time. So what times x is just x? That's going to be 1. Now we do the multiplication. 1 times x, that's x. 1 times 1, that's 1. Okay, put a minus, parentheses, minus sign. X minus x is 0. Minus 1 minus 1 is minus 2. And there's nothing else we can bring down, so that means we're done. So now let's fill in those the formulas that we had on the previous page. So our d of x, always the thing on the bottom, it's x plus 1. The p of x, it's always the thing on the inside, so or the thing on the top. So x to the 4 plus x squared plus 3x minus 1. And then we need our q of x. That's the thing on the top. So x cubed minus x squared plus 2x plus 1. And then r of x, the thing on the bottom. And then we can plug those things into that equation. The p of x is equal to d of x, q of x, plus r of x. So that means x to the 4, x squared plus 3x minus 1 is equal to, so d of x, q of x, so x plus 1, q of x, this piece, and then plus r of x, so minus 2. Okay, so here's sort of everything from this problem. Okay, so these two examples that we just did, the techniques we did to solve them was called long division. Whenever you write, just go to the standard division symbol that you've always seen. This next example, we're going to do a different type of division called synthetic division. And so synthetic division. So we're going to do synthetic division, but on the same problems that we just did, just to show that we can get the same answer both ways. Both ways are fine. Some people may think one's easier than the other, but that's fine. So let's just do those two examples again by using this new technique called synthetic division. So the first example that we did in this class, this video, x cubed plus 3x squared minus x plus 1, x minus 2. Okay, so synthetic division. So what we do for synthetic division, we're going to draw a different sign. That sign, the first thing we're going to draw is this little table. And so what we're going to do is, let's start with the things on the inside. So we look at the top of our division thing, and we want to see what's the highest power we have. And again, that power in this situation is a 3. And so we want a column for an x to the 3 term, an x to the 2 term, an x to the 1 term, and then just your constant term, which is just the number at the very end. And then the numbers we're going to put in each of these columns is just the numbers in front of these variables in the equation. So for example, in front of the x to the 3, there's just a 1. So we're going to put a 1 here. In front of the x squared, that's a 3, so we're going to put a 3 here. In front of our x to the 1, that's just a minus sign, so we're going to put a minus 1 here. And then our constant term, at the very end, that's just 1. Okay, so as far as the table, the inside of the table goes for now, that's all we need. Now on the outside of the table, we're just going to put a number, and that's going to be related to this bottom one. And you always put the opposite of what you see here. So here we see an x minus 2. So instead of putting a minus 2 up here, we're going to put a positive 2. Again, so whatever this number is, you do the opposite up here. Okay, so now this is the first step just to fill out this table. And now just like before, there's going to be a pattern that we keep doing, like a cycle of things. We're just going to keep repeating it until we get to the very end. And that pattern is, the first thing we do is whatever this number is, we're going to take it down. Okay, 1. Then what we're going to do is do 2 times 1. That's 2, and we're going to put that number here. Okay, so now we're going to add these two numbers. That's 5. Put that here. And then do that multiplication thing again. 2 times 5, that's 10. Put the 10 here. We're going to add these two numbers. That's 9. 2 times 9, that's 18. So an 18 goes here. Add these two numbers, and we get 19. And then it's just helpful to put that last thing into a box like that. Okay. And so now we're done. And let's start by filling out the same, just like before, we're going to have, a d of x, a p of x, a q of x, and an r of x. So let's just start with the d of x. Like we said before, the d of x is always a thing on the bottom, x minus 2. P of x is always a thing on the top, x cubed plus 3x squared minus x plus 1. Okay, now the q of x. The q of x is going to come from these. So you're always going to have one number in a box at the very end. The q of x is going to come from the numbers before that. And how we're going to get it, so you see up here how we start with an x to the 3, an x to the 2, and x to the 1. Down here, we're going to start with one less. So down here, this is going to be an x to the 2 column, an x to the 1 column, and then a constant column. So you always start with one less what you have up here. So meaning that we're going to have 1x squared, so x squared. We're going to have 5 x's, so just 5x. And we're going to have a constant term of 9, plus 9. And then this thing in the box is always the remainder. Remainder is 19. So if you look back to the previous problem, Let's get that. Hopefully we got the same answer. Yeah, we did. So that means we didn't make a mistake. So this is the same problem that we just did a second ago. If you see here, we got this, well, the d of x and q of x, or d of x and p of x are the same thing because that's just the original problem. But you see here in the first problem, we got x squared plus 5x plus 9 for our q of x. And that's the same thing here, x squared plus 5x plus 9. And the remainder we get 19. The remainder we get 19. But we, as you could tell, is there's a lot of work on this page, but we didn't really have to do much work on this page, and we still get the same answer. But still, you may like the other version better, that's okay. So anyway, then that's it. You know, we found those 4 things that we need to find for this example. Okay, so let's do the same thing, synthetic division, but with that second example that we did for long division. The second example that we did for long division was x to the 4 plus x squared plus 3x minus 1 divided by x plus 1. Okay, so now let's do synthetic division. Let's draw our table. What's the highest exponent we have in the top? That's an x to the 4. So we're going to need to have an x to the 4 column, an x to the 3, an x to the 2, an x to the 1, and then a constant column. Okay, so then here we're putting the numbers in front of each of these things. So there's a 1x to the 4, so we're going to put a 1 here. If we don't see an x to the 3, which we don't over here, we're going to put a 0. X to the 2, there's a 1. X, okay, that's a 3. Our constant, that's minus 1. So the bottom, now on the bottom here, we have an x plus 1. So since it's a plus 1, we're going to put a minus 1 here. Just like before, you always do the opposite of the sign. Okay, so now let's do all those steps again for synthetic division. Here's a 1, bring it down. This times this is minus 1, we put that here. Add them, we get minus 1. Minus 1 times minus 1 is positive 1. Add these things, we get 2. Minus 1 times 2 is minus 2. Add these things, we get 1. Minus 1 times 1 is minus 1. Add these things, we get minus 2. And just like before, let's put this last thing in a box. Okay, so now let's fill out all those equations. D of x, just like before, the thing on the bottom, x plus 1. P of x, the thing on the top, x to the 4 plus x squared plus 3x minus 1. Okay, now let's do the q of x and the r of x thing. So remember, here we start with an x to the 4. So down here, we're going to start with an x to the 3. X to the 3, x to the 2, x to the 1, constant. Okay, so our q of x is going to be 1x to the 3 minus x squared, 2x, and then plus 1. And then our r of x is this thing in the box, minus 2. And then, let's see, where's our previous one that we did? So this is the answer that we got using the long division. Again, of course, d of x and p of x are the same thing. That was just the original problem. But you see we get the same thing for q of x. We're going to get, x cubed minus x squared plus 2x plus 1. And then our r of x is 2. So again, we got the same answer, which we should. If we don't get the same answer, that means we made a mistake. Okay, so as far as division goes, just doing it at least. These are the 2 methods that we have. And here's several, we just did 2 examples with each method. The last thing from this section that we're going to do is how can we made that, or I made a mention before that we can use this to factor. And so we're going to explain now how can you factor, say for example, so we want to factor x cubed minus 22x minus 21 using division. So we're going to have 2 methods of doing this. This first method, the first and second method are pretty much the same thing, but we're just going to apply something to the second method that makes it a tad bit easier. But so as far as this is the 3.3 section, so there's a couple of questions in 3.3 that have this. So for the 3.3 way, this is the method that you're going to be using for this. So this is the 3.3 method. So what we're going to do, let's just call this f of x. We're going to plug in numbers into here until we find a number that when we plug it in, we get 0. And the numbers that we're going to plug in, so you may be thinking there's like, a trillion numbers to plug in. The way these problems are set up, they're just kind of easy where they're going to be easy to just guess a number and plug it in. So the numbers that we're going to guess to plug in are these ones. So plus minus 1, plus minus 2, plus minus 3, and so on. So we're going to start with 1, plug it in, see if we get 0. If we don't, we're going to move on to -1. And if we don't, we're going to move on to 2. But eventually we're going to get it. It's not going to take too long, just because of the way these problems are set up. So let's start with 1. And we'll explain why we're doing this in a second, but this is just the first step into factoring something like this by using division. So let's start with 1. What happens when we plug 1 into this equation? Well, we're going to get 1 cubed minus 22 times 1 minus 21. But you see this is not going to equal 0. So let's move on to the next one. Let's try -1. We're going to get -1 cubed minus 22 times -1 minus 21. -1 cubed is -1. Minus 22 times -1 is positive 22. And minus 21. If we add all these up, you do see we get 0. So the first thing we get 0 with in this situation is -1. So now what we're going to do is we're going to take this -1 and we're going to do synthetic division with it. -1, draw a synthetic division table. And we're going to do synthetic division with this piece up here, the piece that we're given with. So note that we're starting with an x to the 3, so we're going to need an x to the 3 column, x to the 2, x to the 1, and then a constant. So we have a 1 in front of our x to the 3. We don't have an x squared, so we'll put a 0. And then we have a -22 in front of our x, and our constant is -21. So now let's just do those synthetic division steps. We bring the first one down, multiply them, we get -1. Then we add. -1 times -1, that's positive 1. Then we add again. And then -1 times -21, that's positive 21, and we get 0. So one thing that you know, we can check our work right now, we need to get a 0 in this box. If we plug in one of these numbers, so for example, if we plug in -1, and for example, in this problem we plugged in -1, we get 0. When we do the synthetic division with that number, we need to get 0 down here. If you don't get 0 down here, you either made a mistake doing synthetic division, or you made a mistake plugging in that number and it actually didn't equal 0. Like say, for example, we plugged in 1 and we thought it equals 0, we made a mistake and we put 1 here, we're not going to get a 0 here. We're only going to get a 0 here if when we plug this number into the equation, the answer is 0. Okay, so aside from that, now let's fill out those equations again. The d of x, p of x, q of x, and r of x. Just like before, this is a little bit different. First, the p of x, that's always the thing on the inside of our table. In that situation, the thing we put on the inside was the given equation. X cubed minus 22x minus 21. But before, the d of x was always the thing on the bottom, which we aren't given in this problem. But again, the d of x is also related to this number on the outside. So you remember when we're doing synthetic division, the d of x is always x, and then the opposite of this number. So since that's a -1, it's going to be x plus 1. If you look at our previous one we did synthetic division with, let's use this one. So for example, we did this thing divided by that thing. The thing on the bottom is always our divisor. But we put a 2 here because it was the opposite of this number. So whatever the number here is, it's always just x and then the opposite of that number. So x and the opposite of this number is just x minus 2. And then the same thing happens, in this one. So we have a -1 here, so our divisor is going to be x, and then the opposite of this number. So x plus 1, since the opposite of -1 is a positive 1. Okay, so now the other things. These piece down here, just like last time, that gives us the q of x. So we're starting with an x to the 3. That means we're going to put an x to the 2, an x to the 1, and then a constant. So we're going to have 1x squared, a minus x, and then a minus 21. And this is the remainder. The remainder is 0. Now let's go back to that one equation that we wrote, I think, on the first page. The p of x is equal to d of x, q of x plus r of x. And now let's fill it in with these things right here. P of x, this is the thing we wanted to be factored. The question says factor this thing. So this piece, which is the thing we wanted to factor, equals d of x times q of x. d of x is x plus 1. Q of x is this. But r of x plus 0, so we don't need to add 0. That doesn't change anything. So you see here, when we get a remainder of 0, this piece just factors into the d of x plus q of x, because r of x is 0, so that just goes away. So then that's how we use division. We were able to use division to factor this piece into this piece. And we could keep going if this was factorable. Like we can just use like the the AC method or whatever, but in this situation, we're not going to be able to factor this one. So to factor this completely, it just goes into this times this. Okay, so the next method we're going to talk about, this is going to be from section 3.4. The only difference is, so we're just going to do one more problem, and it's going to be a factoring one, but we're not going to do this guess and check thing with every number, plus minus 1, plus minus 2, plus minus 3. So let's do the next one. So this is section 3.4 stuff. There's only one question we're going to do in here. And the first thing we're going to do is something called the rational roots theorem. And what this is going to tell us, so like the main question we're solving in this one is we want to factor x cubed plus 3x squared minus 10x minus 24. So we said in the last video, when we want to factor, we just pick numbers, like the plus minus 1, plus minus 2, plus minus 3, plus minus 4, and so on until we plug in to get 0. But with the rational roots theorem is going to give us those numbers that we can plug in that are going to be possible zeros. And so we're going to have less numbers that we need to plug in so we can get to our 0 faster. And so the possible zeros for the rational roots theorem, so you take this number at the very end. So just in general, let's write this over here. Say if we have something like an x to the n, plus a1x plus a naught. What we're going to do is we're going to take the factors of a naught divided by the factors of a to the n. So a factor meaning what are the numbers that go into a naught, and factors what are the numbers that go into an, this first number. So if we apply, and all of these possible combinations, those are the possibilities that we could plug in and get 0. They might not be 0, but at least we're going to have just like, a table of ones we could plug in. So we're not just guessing. We're not doing plus minus 1, then plus minus 2, plus minus 3, and so on. So for example, let's start with this. So using this up here, our a naught is the minus 24, and then our an is just 1. So what we want to do then is the factors. These are going to be the numbers that we're going to plug in until we get 0. So the factors of minus 24 divided by the factors of the first term, which is just 1. So what are all the possible factors of minus 24? So what are the numbers that go into minus 24 easily without having like a remainder? So always plus minus 1. What we mean by going into it is if we do 24 divided by this number, it's going to be a whole number. 24 divided by 1 is a whole number, so that goes into it. But also plus minus 2. If we did minus 24 divided by 2 or minus 24 divided by minus 2, we're still going to get a whole number. 3 also goes into it, plus minus 3. Same with 4, so plus minus 4. 5 doesn't, 6 does, plus minus 6. 7 doesn't, 8, 16, 20. Oh, 8 does. And then 12 does. And then the factors of 1, there's only one of them, plus minus 1. So all possible combinations of this, say if we did 1 divided by 1, we're going to get 1. So that's a possibility. 1 divided by minus 1, and we're going to get minus 1. So we're going to get plus minus 1. And if we keep doing that, the only possibilities for zeros are these ones. So plus minus 1, 2, 3, we got 4, 6, 8, 12. So say if the question said, what are all the possible zeros of this? Meaning, what are the only possible numbers that you could plug in and get 0? That's going to be these ones. All these numbers right here, these are the only possible numbers we could plug into this equation and get 0. Possible zeros. However, there's definitely going to be numbers in here that we plug in and we don't get 0. But the main thing is that if there's a number not in this table, there's no chance for us to plug that number in and get 0. So just like before, we're just going to start with these easy ones, plug them in until we find one that gets 0. So let's start with 1. We plug in 1 here. Okay, so we get 1 to the 3 plus 3 times 1 squared, so which is just 3, minus 10 times 1, which is minus 10, and then minus 24. But this doesn't equal 0, so let's move on to the next one. Let's try minus 1. If we plug minus 1 here, we're going to get a minus 1. If we plug minus 1 here, we're going to get a plus 3. Plug a minus 1 here, we're going to get a plus 10, and then minus 24 Again, that doesn't equal 0, so we got to move on to the next one. Let's try 2. Okay, so 2 cubed is 8. 2 squared is 4. 3 times 4 is 12. And then we're going to get minus 20, and then minus 24. But again, that doesn't equal 0. So let's try minus 2. Minus 2 cubed is minus 8. Again, minus 2 cubed is 4. Then times 3 is 12. That's going to be minus 2, so that's going to be positive 20. And then minus 24. So does this one work? So that's going to be 32. And then that's going to be 32. Yeah, this does equal 0. Okay, so we found one. This plus this, that's going to be 32. Minus 8 minus 24, that's minus 32. So we add those together and they go away. So now, just like before, you remember the one that we get to 0. We're going to take that number and do synthetic division with that number. So we take the minus 2. This is just like the same thing as we did in the previous problem. So we take the thing that we gave as 0, we put it right here. Now we're doing synthetic division with this piece. So the biggest thing we see up here is an x to the 3. So we need our x to the 3 column. 2, 1, constant. Okay, the number in front of our x to the 3, that's just 1. In front of the x squared, that's 3. In front of the x, that's minus 10. And the constant term is minus 24. And now let's do synthetic division. Bring down the first one. That times that's minus 2. Add them, we get 1. That times that's minus 2. Right, yeah. Add these, we get minus 12. That times that's 24. And then add these things, we get 0. Okay, so now we can fill out the whole equation chart. For example, the d of x. Like we said before, the d of x is going to come from this number. It's going to be x and then the opposite of this number. So here we have a minus 2, so it's going to be x plus 2. And that's how it's always going to be for the d of x. Whatever that number is here, you put an x and then the opposite of this number. The p of x, that's the thing given to us up here, the thing we wanted to factor. The q of x, so again, we start with an x to the 3, so this is going to be an x squared column, x to the 1 column, a constant column. So we have 1x squared, 1x, and then minus 12. And then our r of x, since we didn't, we should get this 0. We can't have an r of x here because we plugged minus 2 in and we got 0. So this needs to be a 0. So now let's fill out that equation. Let's try to write this small in here. That equation that p of x is equal to d of x, q of x, plus r of x. R of x is 0, so that just goes away in this one. So our p of x is this piece. Remember, this is the thing we wanted to factor. So that piece equals d of x, x plus 2, times q of x, this piece. Okay, so we did our first step of factoring. You see, we were able to factor this into this. And I mean, as far as I'm aware, there's going to be no other way to factor this except using this technique. Because we're not going to be able to use the factoring by grouping in this problem. And also, I mean, the AC method doesn't work. The AC method only works as if we're dealing with an x squared. But here we have an x to the 3. So this whole thing, we want to factor this problem, this piece right here completely. But we can factor one more step. We can factor this piece. So we're going to have another equal sign. So we're just going to bring down that x plus 2. But we're able to factor this one. So there's only a 1 in front of the x squared. So put an x here and an x here. And we're looking for the numbers that multiply up to minus 12 and then add up to 1. So if we put a plus 4 and a minus 3, x plus 4, or sorry, 4 times minus 3 is minus 12. 4 plus minus 3 is 1. So then we'd factor this whole piece into these two guys and just rewrite this one. So then the final answer is just going to be this. We can factor that original problem, this, into these three things all together.